And we are recording the meeting tonight. But I do want to thank all of you that have shown up, both virtually and in person. We have one new person that I know of. Would you mind standing up and telling us a little something
John
about
Tyree, I live in Virginia Beach, and just fiddle around in the garage with some pretty good sized tools, but I haven't built a whole lot. But I'm interested in. Larry here lives down the street from me and told me about the meeting tonight, so I'm sort of anxious to come down and see what's going on in Tidewater.
Yep. Well, welcome.
And the name's John Tyree.
Okay, John, thank you. Anyone else? I think we got everyone else are actual members. One thing I do want to say is I need to thank both Chris and Terry and Gary for what they have done to keep the guild going, both virtually and we had a little bit of an issue with emails. We're now up to 109, I think. 109 people receiving the email. So we've consolidated the email list, and it's actually working a whole lot better. But I hope you were not offended by any of my emails that I try to send out every weekend. You can see my sort of sick sense of humor. You know, I do a Google search and try to find something just to liven things up. We've needed something to liven us up over the last year and a half. And it's been a long haul for everybody. Not just the people that have made an effort to get here, but everyone else. So I do want to officially welcome you back. We hope that we will continue to expand the numbers of people coming in, and we can eventually, at some point, hopefully, get to just an in-person meeting, and more and more people can come. So I want to thank all of you that are both here in person and here virtually. I do want to show you one thing. This is my notebook. You remember I only had 2 meetings here before we went with COVID. And this is all the stuff that I've been collecting. Of course, this is a copy of each one of those silly emails that I sent out. So I've got a record of all of that. If any of you, for any reason, want to go back and see anything, I've got a record of that. But it has been a long haul, but we are on the road to recovery, and I think we're going to be there very, very soon. I did ask Brett if he wanted to see anything from Woodcraft. Ed said he was going to try to be here. The owner of Woodcraft was going to try to be here, but he said that there was, I think he's got some family things going on, some family coming in. So he will not be able to be here with us. But I do want to thank, on behalf of everyone here at Woodcraft, all of you for continuing to support this organization that allows us to meet here every month. That's the only way they can stay going, is if we and other members of people that are actually woodworkers support that particular group. Because a lot of businesses, as you have seen over the last year and a half, have not made it. The ones that you have as an interest, if you're doing any remodeling or anything, Home Depot, Lowe's, those type places, they flourish. But a lot of small businesses have not. So it's good for us to continue to support Woodcraft. The way we're going to operate it tonight is we do have an excellent presentation tonight. Terry has been working a lot to get ready for this, and being a former industrial arts teacher, I can tell you, one thing that you do when you're giving a demonstration is you always do it in advance before you show it to someone else. And I think Terry has gone above and beyond here in preparation for this particular presentation. I think you will enjoy what he's going to be talking about and what he's going to show you. You will see some of the things that he has actually done, his design, and all of that. So I do want to say that. But what we will do is we'll have the presentation. At the end of that, we will have the raffles, and as you see, we've got a few people trying to gather some of the things that Terry has actually created, and then we'll have any show and tell that we have, and any discussion that we have, for the guild, any just open discussion at the end. Yeah. So at this time, I'm going to turn it over to Greg, and Greg is going to introduce Terry and get us going with the presentation. Okay.
Go ahead.
Okay, but anyway, Terry is going to agree to do a presentation with his laser tonight, so I'm not going to waste your time. I'm going to turn it over to Terry and let him go with it. So, without further ado, here's Terry.
Scary.
Thank you.
All right, so I'm a little embarrassed that he said, hey, you do this in advance before you show anybody, because all the stuff over here was done this weekend. So it wasn't exactly, hang on. Wasn't exactly very far in advance. And in fact, as of a couple of days ago, I wasn't positive that I was actually going to even have a laser operating to do these trinkets. So I'm an engineer. I do aerospace hardware, so I actually play with lasers in my day job, and so I wanted to start seeing, well, what can I do with this at home? And so I took about the hardest route you could possibly imagine to learn how to do lasers and start doing them. So I'm going to be talking about that. If you're an Austin Powers fan, he was very fixated on sharks with lasers on their head. All he wanted was a freaking shark with lasers on his head. Can you duplicate bring the PowerPoint back up? So it's particularly comical because some of our past presentations was on a shark CNC, and you were showing some of your lasers. John? I'm sorry. Bob. I'm sorry about that. So Bob so recently we just had a CNC presentation with a shark. The shark sells a laser on it, so it's kind of funny to have a freaking shark with a laser on its head. Well, that one didn't work out as well as I'd hoped. So what I really wanted to do tonight is give you just a familiarity of lasers, the technology, how they're used today. I want to give you some confidence because this is really not that hard. I took the really hard path. We like to say at NASA that we do hard things. And I always add my little cynicism to it and say, if they aren't hard, we make them that way. So, and there's my attempt at a little humor along the way. So, we've already kind of talked about the topics, but I'm going to cover a little bit of the hazards because the last thing I want to do is turn you guys loose on something that, turns you into, that cripples your eye. And it is a very real possibility with these lasers. They are like any other industrial tool, except that they flip around and basically they project out at a very long distance. So I'll cover that a little bit and what, how to avoid that. And then I'm gonna give you a sample, and don't take anything I say today as an endorsement for a product. Is simply my experience. Along the way, we're going to give you a tour of the tools that I use. Like I said, I'm going to give you the broad overview. We'll do a tour of some of these tools that I've played with. I made some trinkets over the weekend, and we're going to go ahead and just raffle them off. If you're interested in them, and if somebody online is interested in them, in getting in on the raffle, you can just IM Chris. The presentation, it'll be in my name, Terry Nienaber, on the Zoom meeting. And you can pay at a later date if you want. Just tell him how many raffle tickets of which one. I'll break it down basically. Can you flip over to the overhead boom? So we've got these Contigo cups. We've got 2 of them. They're they're 1 or 2 is the raffle. And then I've got just a stack of 4 coasters is the other one. And those are items 3 and 4. So 1 and 2 if you want a cup, 3 and 4 if you want a batch of 4 coasters. And these are all just laser engraved, and I'll go over that. We've got some other little pieces of wood. There's 2 versions of this, and these are, I'm not gonna lie, these are just pieces of scrap lumber I had. One's hickory. I think that was number 5.
Which one? One on the right hand? That one's number 6.
6. So this was number 6. A little bamboo cutting board in the dollar store was number 7.
Yep.
And then there's a second one of these that's in oak. That's number 5. If that wasn't confusing for you, then I'll see what I can do in the rest of the presentation. Thanks, Chris. So anyways, these are all things that I did over the weekend. So these aren't difficult. Each one of these items is somewhere between 20 minutes for the coasters to like 40, 45 minutes for the cups. So that gives you kind of an idea of, and I haven't optimized these burns all that well, and I'll get into that, but gives you an idea. It's simply a scanning process across the part. So what got me into this? Number one, like I said, I'm vaguely familiar with lasers and particularly laser diodes. And when you look online, actually it was a friend of mine asked me if I could make a cutting board for him and engrave his grandmother's, his deceased grandmother had this recipe that everybody liked. And so he gave me the handwritten recipe. And I managed to put it into a graphic, like a JPEG, and put it into that. And I actually started making it with one laser. But he basically, let me reverse. He came to me and he said, "Oh, my wife saw this on Etsy. She wants to do this."
Yeah.
So if you're like me, you try and keep the spouses off of HGTV and Etsy. Those are yeah. But I do have the philosophy of if somebody's going to give me something like that, then I get a tool out of it. So I started looking online, and you can get these things all day long on Etsy and eBay and things. You can get stuff sort of done, or you can send them an image and they'll process it and take your best shot with them throwing it on the laser engraving of a product that they're selling. They're actually not terribly expensive. If you pull up the presentation again. They're not terribly expensive. These are tough to see, but they'll start at anywhere from $16 for a small piece like these things are, out to $100 for something nice and big. And they'll do grayscale, and they'll do a lot of fancy stuff that I haven't quite figured out how to do yet, but I'm pretty sure I can. It's just time. So, got through all that, and I said, well, this is kind of cool, and we could just order this for him. And then I said, but what fun is that going to be? Because then I don't get any tools out of it. So I started my little thing. Now, a little side story. The Nienaber is a term that my father-in-law coined. My last name is Nienaber, which is a mouthful already. So he came home one time and he was like, "So what's going on in the Nienaber?" That's what he calls my shop, because when he walks into it, it really feels like he's in a whole different area. And so it began. So this is the first time, one of the first sets of parts I was demonstrating. So this is it in action. And you'll see it rastering back and forth. That's this little guy over here. I actually had a version before that that I did. Actually, I built my own little CNC a while back. I say a while back. My CNC started 20 years ago, and I've replaced every part on it, in various ways, shapes, and forms, to where there's none of the original parts still on it, literally. It went from controller to steppers to new motors to new controller to eventually I had a whole new platform that I moved the old controller and motors on, so it's unrecognizable. But my first attempt at this was actually just to put it on the CNC and use it that way. Now there are reasons I'll try and go into later why that wasn't necessarily a good idea for my system, but it works. So that was my segue into the next phase of the Nienaber. I think most people probably would guess that laser is a term that came from an acronym. So it originally came from light amplification by stimulated emission of radiation. No idea who came up with that. Very scientific, but it has very much become shorthand and all lowercase because nobody actually remembers what the heck it came from. So it actually has become a term And they actually even use it as a verb, lasering, and there's a threshold at which you get above a certain power level that it starts lasing, where it goes from not on to visible light. And so it's kind of interesting. But what it is unlike a light bulb where you just pump electricity into it and it starts to emit because it just gets hot. A laser does something a little different. The material inside the laser is selected with a certain makeup that makes the electrons get really excited and go into an unstable orbit. It's kind of like that extra passing lane on the racetrack. Except that when they're out there, they can't stay out there for very long and they duck back in. Well, when they duck back in, they lose photons. They generate photons, which basically become light. And so the light starts creating an academy. And the old style, for years and years, the lasers were basically a tube. And they look like an old hygrometer, if you ever knew the old hygrometers. They're usually, let's say it's that big, and they're filled with a gas. Sometimes they're filled with a liquid. And when you're bombarding it with power, it excites those electrons, and eventually the electrons fade. They create photons. Well, you have basically the photons bouncing back and forth against mirrors down this tube. And they eventually start bouncing back and forth, and there's a little tiny pinhole at the end, I'll call it, where it can get through. And so by the time the light comes out, the light is naturally collimated. What does that mean? The light that comes out, so let me back up for the thought-provoking question of why can you have a 100-watt light bulb, LED, whatever, the 100-watt equivalent, or let's say an incandescent light, why does that not cut anything? Even if you put something right down on it, it doesn't really cut something. Well, lasers are such that because they're all collimated and focused, and they're coming out that little tiny pinhole, they're all moving in exactly the same collimated line. If I had an array of these, you wouldn't see them. If you're over here, you wouldn't see the light over here because it's collimated. It's not emitting in a broad spectrum like a light bulb is. That's actually part of the problem with the LED light bulbs, is they're very focused. So the first ones that came out, if you ever got them, you'd screw them in and there'd be a bright spot right under them and everything else was dim. It just didn't spread out. Well, they've kind of addressed that. They've gotten things that diffuse it and artificially move it out and spread it out. It's actually difficult for LEDs to do that. So this is a general thing with the way laser waves are created. They come out collimated. So what that really means is you've got basically 1 in millions of times of distance or of difference. If I'm 10 feet out, that light is all coming down on a pinhead because it's collimated. In theory, it would still be a pinhead. It might, laser pointers, if you ever point the laser pointer, it might be a little BB-sized dot here, and by back there, it's still only maybe a dime size. It's still really tight. So the problem with the lasers, including what makes them powerful and dangerous as hell, is that at that distance, there's still a lot of power in there that your retina does not like. So all it takes is 1/4 of a second of a flash across your eyeball in a straight line from that laser, and you very much will lose a good part of your sight. So, like I said, I want to give you guys confidence to use, but a really healthy respect for the danger associated with a laser. So I'm going to go over some pointers of, okay, how do you keep, how do you safely use it? So I kind of alluded to the type of laser that for years and years you would have seen, particularly in industry, was a CO2 or other gas laser. And it's a tube. It's very much a stationary tube. So if you've got, I'll go over the positioning systems in a little bit, but it used to be that you wouldn't be moving that tube around. That wouldn't be part of your moving head. You're just going to point it out there and let it bounce around and hit the part through mirrors. That's how collimated and precise it is you can actually just use mirrors to bounce it around, and 3 or 4 feet of travel was no big deal for it to hit and still burn your part. That's how potent that beam is. So then that was working out pretty well. CO2 was by far, to my knowledge, the most common. Then they came up with a fiber laser for industrial use. Fiber lasers, the CO2 lasers, let me back up, do pretty well. And usually for like a hobby shop, they're gonna be maybe 40 to 100 optical watts. And I'll come back to the optical designation there in a little bit. But the CO2 lasers, it was fairly easy to get them there. You had to cool the tube. There was a lot of waste heat. So for every watt that it's creating an optical power out there, you might have 10 or more watts in waste heat because it just isn't an efficient transfer. So you've got to cool that little tube, usually with water, and try and keep recirculating. If your recirculation pump goes down, your laser can toast like that. So it's like running your car without oil. Or without a radiator. And so the problem is each of these has that's the other thing I didn't talk about, what makes it cut, very focused wavelength. So you can think of wavelength like the color. I say like the color because when it's in visible spectrum, the things that our eyes can see, it is color. So a laser LED for these machines is usually blue, which equates to 440 nanometer wavelengths. Doesn't really mean much to you. I've got a color chart in the backup. I could show you kind of the visible spectrum, but that's in the blue area. If you go a little bit to one side, you get into ultraviolet, which we can't see. You go to the other far end, you get to infrared, which you can't see. And so CO2 goes out into that UV spectrum that you can't see. So CO2 lasers have a little bit of extra danger to them in that you don't see it coming. Literally, your eye doesn't know it's hitting it. And so you kind of have to worry about that. The blue lasers you do see. There's a little bit of eye strain if I'm too close or whatever to it. I know I've overdone it.
Like welding or something.
Yep, except I'd be willing to bet probably 3/4 of you have had welder's eye at some point or knew somebody very close that did. It's a painful, miserable experience. This is probably worse. It may not be as painful, but you probably aren't going to see right after this. And so one of the wavelengths here, I think it's the fiber wavelength at about 1064 nanometers, is actually used for eye surgery because it's got an interesting thing. The other thing that makes lasers cut so well is that they are designed to cut in a frequency that the material responds nicely to, i.e. it absorbs it very consistently. Part of the problem with wood is that wood doesn't.
It's not consistent.
It's not consistent. It's like staining it, except you're burning it. Parts of it'll burn, parts of it'll just sort of transmit through, and it'll burn underneath. So part of the problem with fiber at 1000 nanometers, 1064 nanometers, it's partly transmission. It transmits partly through cellulose and organic materials. So the problem with the fiber lasers, I got a friend of mine has a fiber laser, and he can mark the heck out of steel with it because it really penetrates steel. It's a very high power laser. But he tried to do wood, and he was like, I can't get it to burn some of this wood. Like, I can burn this stainless steel, but the wood isn't touching it. And then all of a sudden it'll get over here and it'll burn. But it literally, like, it wasn't even there. Well, there are lots of warnings out there about don't use fiber lasers on wood because it can actually penetrate down through it, like heating something in the microwave, and it'll heat it from the inside out because it'll hit something down inside that suddenly will absorb it, and it'll actually start charring from the inside, and people have started fires in wood because it smolders from underneath. So fiber lasers, not good for woodcraft. Woodcrafting, whatever. And so then we get into the laser diodes. Laser diodes were very limited for a lot of years because we were having it wasn't until, it's within my engineering career that they figured out how to make some of these colors in laser diodes. So red's been around forever, right? For diodes. Well, there was a time, a lot of you probably remember when you couldn't buy a blue LED. Well, all of a sudden now blue LEDs are everywhere. They've figured out how to make efficiently and optimally the blue and green lasers. That opened up a whole new world because red isn't a great color for absorption on wood. Blue is fantastic. It's almost completely absorbing in the blue spectrum. So blue lasers are phenomenal compared to some of the other ones. For whatever reason, fiber doesn't like it. Too much of it transmits through. Like I said, I started to say your eyeball. They use basically the fiber technology to create that 1,000 nanometer because it transmits through the front of the eye and goes all the way to the back. And the back is where they want to do the surgery. So it goes right through the part they don't want to touch and it hits the spot that it does. So it's perfect unless you didn't want it there. So, and you don't have a blink reflex in that area because your eyes don't sense it. Blues, you will blink, but it may, if it was a direct hit, it's going to be too late. So that kind of hits the big ones. Oh, I'll do a public service announcement. Green lasers, everybody gets really excited about the green pointers. And they're like, wow, that's really bright. That's really cool. Ooh, I bet that's not even legal. I'll take one. Stay away from them. The green itself isn't the problem. Actually, your eyeball is the most sensitive. You have the biggest reaction in your brain to green. It sees it the best. Biggest signal to response. But unfortunately, when they create it, they actually create it at a lower, I think it's a lower frequency, and they use a frequency doubler inside to play tricks with how that wave comes out. If they do it right, they put a filter and capture that higher wave, the other wavelength. It's a frequency doubler, so it's half the wavelength. If they do it right, they capture that wavelength in the system. If they don't do it right, which most of the Chinese companies they've found, it's a real crapshoot. If you get a cheap green laser, it has that frequency that you can't see. And it's at enormously dangerous levels. So a hit with that could blind you. So stay away from green lasers. Not a good idea.
Is that like a spurious?
Yeah. I don't know.
Not spurious, it's intentional. It's just not one filter.
Right. They just omitted the little filter in there that is supposed to take that out. So, but I've seen lots of studies on that. It's a hit and miss. Don't trust your eyes. Do it to something that's got a known flaw potentially to it. You can actually check it. There's ways to check it online, but that's just, you don't need green lasers. That was my public service announcement in that area. So there's more information in here, and I kind of go through if this gets posted. Microphone isn't.
I got it.
Okay. Let me get this up closer to mine.
Yep, move that up closer.
So I think I've hit all of this. Oh, the other thing I didn't talk about was it'll burn you too. One of my newbie lessons. So where is that? Okay, well, I don't remember where I stowed it. I didn't remember pulling it out. But this is the laser head. So it's a tiny little thing. It's this guy here in the overhead. The laser diode itself is a little tiny, like half the size in either dimension, maybe even a quarter of the size in either dimension of a thimble. That's all that's creating all this light. The rest of this is heat sink, like trying to draw the heat away because it gets hot as hell. So when I first got it, of course, I wanted to start messing around with it. And you get this long cable, the cables dwarf the damn laser sometimes. And I had the cables laying out, and the thing essentially like slipped and went whoosh. And it's basically like you wouldn't treat a gun, you wouldn't point the gun at anything you were afraid of, and let it fling across the table with a loaded, with a trigger off of safety, etc. Well, this is like a machine gun. It's going across and it's going to hit whatever it hits because it's live. And it stung. I had basically a sunburn right across my arm from literally the thing just swiping across my arm. So you can imagine if it's hitting your arm for any amount of time, anywhere near focus, it's going to do damage. So, skin, which is a good segue into eyewear. If you get a cheap laser system, they are invariably going to send you a pair that looks like this. Yeah, it's funny. Sears used to sell these with their lasers, so that you put this on so that you can see the red better. The thing you got to worry about with all of the safety glasses is it may not be intuitive, and the guy selling it to you may not give a darn whether they're selling you something that's really tuned for your laser or not. Throw these in the trash and get yourself some laser goggles that actually where they came from, what frequency, and what optical density they are. Because you can see these came with one of my lasers. These came with a much more reputable laser company. I still am with these. These are actually marked. Okay, I'm okay with these. These came from a company, actually a U.S. company down in Texas that tests them. And I was amazed because they call this an OD2. If this is an OD2, this is nothing, because OD2 is nothing on the scale. I wanted to see an OD6. OD is the order of magnitude. It doesn't. That's not the O, but I think it's
optical density.
Optical density. And so the optical density basically is the logarithmic scale. So for every number on it, it went up it doubles. And so 2 to 6 is a huge difference. Now the interesting thing that I say, I was like, don't get don't get too confident in somebody giving you something that makes sense. I mean, the red's fine, probably. I've seen them sell basically bluish green versions of these with blue lasers, which I really don't believe is probably doing anything for you. But they're usually lower powered lasers, so they know they can get away with it, most likely, and they don't really care. What are you going to do? They're going to close shop and start selling under another name because there was no brand to begin with. Again, don't trust your eyes to these guys. These I was much more comfortable with, and if I use this over the top of it, there's no question these are better. A friend of mine gave me some laser plastic that was on a commercial laser, but it was for a fiber laser. And when you put that up in front of it, because I was going to make an enclosure with that. Yeah, well, I mean, this was for a laser. Dumb us at the time, we're like, oh, that should be great, and I didn't know much about the frequencies and everything at the time. When I put that up there and it shines through, I can still see blue, which means it's not filtering blue, because blue is the only major color that thing is putting out that's harmful. I shouldn't be able to see blue. So then I got these. These are OD6. That's like 1 in, I don't know, millions of density difference. And I'm like, really? Because I can see everything just fine. It's a little bit of a yellow hue, but I don't see the blue come through. And this is from a company that certifies to the national standard that you're supposed to certify to. There's an international and a national. And so I was looking for a company. This is from a company, Free Mascot is their name, and it comes with a cert. I didn't go to the point of like checking their certs and everything, but I almost threw them back in the drawer and wasn't going to use them, but I actually have gotten comfortable with them. I had no eye strain from that. So this laser came with a little baffle on the front that was green. Again, it was a much lower powered laser, so.
That one just does the work just under that little thing.
Yep. And I'll come back to a cautionary note on that as well. So some points, like I said, look for places that are willing to engrave, that they've marked what the optical frequency that you should care about is, and it'll mark an OD. I think the reason that they only call these optical density 2 is they give a pretty wide range of frequencies. It might be really good in the 445, but not in some of the other range, because they have to take the lowest of that range. It'll say it's at least OD2 in this whole span, but the curve kind of does this. In case somebody tries to tell you that there's glasses that will cover the full spectrum, it's called a wall. It's not possible. You want glasses that filter out the color region or the frequency waves that you are interested in filtering out, and still allow you to see in the other frequencies. And it's pretty stark. Like different materials and different coatings will have dead bands where it lets everything through in this region, and that's your visible region that you want to still be able to see. But depending on what you're trying to filter out, it'll take care of other regions. So that's just kind of a change the oil in your light bulb, in your headlamps kind of thing. If somebody ever tried to tell you, these are good for all lasers, there's no such thing. Buy from reputable sources. Don't trust no names on any place. And then these glasses are really your last resort. What you really want to be doing is controlling the laser. I'm showing you this, and I'm not advocating anybody get this, because it's very difficult to control the laser beam. I could never operate this at my work. I could not get it safe enough for a operating license. Well, I shouldn't say never. It would be very difficult. We would probably have to lock down the room, put laser signs on the outside as a minimum. People would have to be wearing all the proper glasses. They don't like the potential of a problem. So you don't want somebody walking in on your shop. This is good practice anyway. You try to be comfortable that nobody's going to walk up on you when you're operating equipment and get in an area that is dangerous to them. This is an area that's dangerous, and like I said, if that reflects off, it can get a perfect reflection and hit you in the eyeball. So, you can have a shiny surface, a mirror-like surface that it crosses, and that laser beam is now live.
I was just wondering what you did that before, because I assumed that laser's always pointed down.
So your first rule is point it somewhere that you know. Watch those reflections. Secure your area. Pets. A lot of people say, "Hey, my cat likes to go up and and get near it." That's not gonna end well for you or the cat. So control your area, just like any other tool, but with a little more diligence. I have an enclosure that I put that one in. This one's brand new. I haven't built an enclosure for it yet. Part of the reason I haven't operated it. But I'm gonna basically create an enclosure that keeps that stray light from getting loose, so that I can do other things. Because a burn of this size could take days. Depending on how you're doing it. You want to be able to do other stuff while it's going, because I don't really like to leave it unattended either.
Terry, there used to be a thing called a maser, microwave stimulation or radiation. Are they still around or not?
I've never heard that term.
Oh.
Not saying it is or isn't.
They're still around.
They're still around.
What is the industry? Do you know? Masers?
I don't know. It was just in my physics class.
It can be similar purposes, but it was originally developed in conjunction with communications.
Okay. So the lasers that I've worked with are mostly for like earth science kind of references. Lasers are beautiful because they give you a very, very focused, narrow bandwidth, very high intensity. They're very stable. You use them as a reference to tell your performance on your sensors and things. This is on the. So this is an intro to the laser safety. Do other stuff. Go get comfortable with yourself. For yourself. I'm not an expert. I just stayed at a Holiday Inn Express I've given a couple of things that I've looked at, for my own training or familiarity, as well as talked to some folks on site. One of the things I wanted to point out is this, can't really see my pointer coming through for some reason. For those of you in the room, oh, I know why. Crap. It's because of the way I'm projecting. Oh well. For those of you in the room, you can see what I was talking about. This is where it is an OD 4 to 6 in this particular material. And so that's the amount that it's filtering out. You get up here, it's peaking right at 445, which is what I want, the blue. But you can see it kind of swings pretty wildly. This is 1 in a million. So, strength gets through. So I'm getting very, very, very little blue at an OD 4 or 6 in this case. So that was what I was looking for. But then you get down into, so that's the blue. Green is around, between 5 and 550. And then red's out there in 550 to 600. So with these glasses, you would get a lot of red through it. So if that helps you. That kind of gives you a visual of what it's filtering and what they can do. Different materials might flip that around and it'll filter out the red better than the lower.
So what you're saying is even a nanosecond hurts you.
Yes. Well, in the millisecond, certainly. I mean, it's still heat generated, but it's really fast because it's at the cellular level, especially in your eyes. So it's better just not to go there, not to take that chance. And then, so wood, if you remember a while back, we had a presentation on pyrography. And somebody brought up, hey, some woods are not so good for you if you burn. Like you want to watch the vents. It's going to be the same thing here. You are literally burning the wood. That's all this is doing. You're just creating a very localized hot spot. So same ventilation for that is here. It's going to be a lot more prolific here. I'm trying to set up my vent right now. It's not the greatest. I try and just ventilate my shop really well, but there's two reasons to vent. There's my safety, of course, and then there is the coating out on the optics. So if all that smoke is generating and it starts to play out on the optics of the laser, so there's a little laser diode in there, and then there's a little focusing element down there to pin it really down into a pinhole. About 10 thousandths is what I try to get mine down to, 10 to 15 thousandths. That's 160. It's 10 thousandths of an inch, so about three to 5 hairs is kind of what you go for. And so as you're cutting, it's generating those fumes. It's boiling off. Now most of these will have a little fan that pushes the air past the lens now. They're getting better at that. And so they call it forced air. And a lot of people, to make it cut faster, will actually start to blow air through a little hypodermic needle right where it's contacting the wood to try and push, or whatever, to try and push the fumes away to keep it away from that. And then, what you would ideally do is you'd have a little needle pointed at the same spot that it's focused on. Try and brush it away, and by getting rid of it like that, you're pushing the particles that you're burning off away, and it'll cut faster too. It'll cut cleaner. And then the idea is, you did that. Now in your enclosure, you want an exhaust fan somewhere, or you want a little puck over the top of it to pull it away. This one's simply, this is as cheap as you get, and all it did was it had a little computer fan that pushed, the smoke away. And so I use a little inline dryer vent thing. Sorry, I'm sliding around a lot. I use a little dryer vent on the side of my enclosure, and then I'm trying to get that to where I go to the outside window. I just haven't gotten to that little part yet. But you really got to be careful about plastics. you're gonna get tempted. If you're like me, you start looking around and anything that looks like you might be able to burn, you start throwing it under the laser. That's a little dangerous. So there's some things to watch out for. You should never cut things like ABS. That's sort of akin to PVC, anything with vinyl in it. There's some really nasty toxic and caustic stuff that comes off from burning those.
Face masks out much at all there, you reckon?
Not face masks. You could do a respirator, but some of it is really caustic too. Toxic is harmful to you. Caustic is harmful to everything around you. That's the way I like to think of that. It can start to really raise hell on your screws and mechanisms and just make things ugly if you get that stuff sitting around. So it's really best to just get that stuff out of there. It's like painting or anything else. You want to do the exhaust. Wow.
Salt treated lumber.
Yeah, I'd probably. The salt treatment probably isn't as bad as the old arsenic. So, you missed the video, but Austin Power's counterpart there, he calls him my cycloptic colleague, which I thought was appropriate. He had one eye. He had an eye patch. So I tried to carry it on there and say, don't be a cycloptic colleague, protect your eyes. Control the laser, don't use it freehand. That's just not a good idea to try and freehand anything with the laser. Get it mounted in something. Most of you are probably going to be buying it in a kit, or a complete system. Just don't let it sit on the table and plug it in and play with it. I already talked about all that. There's some terminology that I'm mostly talking about engraving. Engraving is what we think of as you're doing a partial cut into it. You'll hear people, if you start looking online, talk about part marking. Marking is a more general category. It really literally means you've created a visible mark on the part. It could have been through burning or destruction of parts of the surface, or it could simply be to apply a chemical process, create a chemical reaction there, like like activate an acid locally or something, and everything that you didn't touch is fine. It could be melting a toner type thing, like your laser printer on your paper does, where it's got particles, and when the laser hits it, it fuses it to the metal. So just be aware if somebody says, oh, this is a part marker, they might be referring to something other than engraving. So you got to probe, okay, well, engraving is a subset of marking. And then, of course, cutting. So I know, Pat does some things where he engraves stuff and cuts it. He has somebody do it for him. Laser diodes are getting to that point where you could probably use them for the cutting part of it. And it just comes down to the amount of power and the amount of time you spend. So I have no doubt that this latest system that I bought can cut through up to, I think they basically say like 5 millimeter, which is, what is that? Yeah, 1/4 of an inch. 3/8 of an inch, I think it could probably do. But it might take you a few passes, and then it comes down to how bad you chart it in the process. So the hotter the spot and the, that you're creating, the more it tends to char, so you can turn the power down, but then you got to turn the feed down, and you play games with all that and try and get the effect that you want. I know that I tend to use technology because my background is more of machining and fabrication of metals and things. So I cheat a lot and use milling machines and things. And Ray Jernigan was funny. He when I described what I do in woodworking and everything, he was like, "Oh, you're one of those." Yeah.
A wood machinist.
Yeah. It's like you use machines for everything. Well, the interesting thing with this is you can create a lot of different effects with lasers. Like you can get it more rustic looking, you can defocus the laser, you can do different things. So there is an art to it. One of the other things I didn't show, this was an experiment, total experiment. Sorry, let me turn off my microphone while I'm crinkling. This is fine. So this is glass, just simple beer bottle. And what you're seeing there, the gold is actually fracturing the crystals of the glass. And so
That's just like a natural coloration from
it's a natural way it's
It's like frosting.
It's like frosting.
Yeah.
So it came out alright. It cracked the heck out of the glass, which is why all the tape around there. Apparently, you have to control the backside of glass. And by the way, it only works with colored glass with a 440 wavelength because.
So you couldn't do it on clear.
Oh, hey, yeah, your audio's still on.
Okay, sorry. Now I should be back. Yeah, you can't. Well, so there's tricks to do it with clear too. You can like paint the backside of it so it collects the heat on the backside. I haven't played with all that. I'm less enamored with the glass but it was an interesting effect. So when you're looking, I think we're probably getting to a pretty good stopping point. I'll just say that there are the different components. Obviously, we've talked about the laser head. You can think of the laser head as basically being your router with a router bit in it. And you can mount that router and a router bit in whatever the heck you want. It can be a platform like this. It can be my 3D printer. It can be, CNC. It's just a router type thing. You just want to move it. There's an interesting version of it that actually it doesn't actually move in what we call Cartesian. It moves in radians. And so it literally just points it to different locations from one spot and scans it out that way. This one is Cartesian, but there's a version that isn't much bigger than that just projects it down onto, in fact, it's this one on the left here. It literally is just a little can on the top, and it's got, I would guess, probably mirrors that are moving that laser beam back and forth and tracing it. And they work fine for little areas, but at some point they're going to start to distort, and the level of the lasing is going to degrade over the distance. And so in a short area, it's great. In a longer area, it's going to have to do other things to correct for that distortion to reach out because it's not a linear path. And then that middle section is kind of a smaller version of what you see here. My 3D printer is it's another Cartesian. This used to have a 3D, let me bring it over. So about, 3 years ago, maybe, I got on the 3D printing bandwagon just to try it out. What the heck? This was about $250, I think. And so it had a little extruder, and 3D printing is basically a hot glue gun with a feeder on it that moves back and forth, and it just positions it and adds it looks like a weed eater string, feeds it into the hot end, they call it, and literally builds it up like you're frosting a cake. And it just makes it as tall and whatever as you want, and there's all kinds of software that makes that happen. It was a very finicky process. I kind of got grumpy with it. I went back to machining, but I had this 3D printer sitting there. My CNC wasn't working all that well because CNCs don't necessarily care about starting and slowing down in corners and things. And I was having a hard time getting my controller you can't just get somewhere with the mass of a CNC and just stop on a dime and shut the laser off. In the meantime, all of that, and you'll see it actually on on some of these, I didn't have it set right, and you'll see a little bit deeper burn on the ends. That's where the machine is slowing down. A machine like this has very little mass that it's moving, so it can stop pretty close to on a dime, but you still get that. You still get that instantaneous, it's burning a little hot right there. So until it gets up to speed. The way you do that, if you're rastering, you can run past it and it cuts the laser on the fly. And so then it eliminates that problem. I was still too new on the software to have noticed that I had that turned off yet. On the back of some of these parts, you'll actually see some patterns where I figured out the test patterns, and it literally makes little squares in a grid at different speeds and powers, and shows you. So some of these, I got smart enough at it that I figured out how to do that. In fact, I did one on this sample piece of cork, if you can do the overhead.
Come this way.
And so I tailored, once you kind of zero in, you can do a coarse one, and then if you want to get finer, you tell it to program in a little bit finer grid in the area that you thought you would like. So in this case, I had gotten pretty close on my first cut, and I decided, you basically want to pick the fastest that you were getting good, precise cut on and off, and then look at the power level that you were getting the crispest or the effect that you want. And so I kind of dialed that in for doing the posters.
Terry, is the software for this similar to CNC engraving?
It is very similar to, what were you using, VCarve, Bob?
Yes.
So Bob was using VCarve. It's very similar to VCarve. In fact, VCarve probably has a laser function on it.
I know NextWave has.
NextWave does it?
Purchase a program that adds on to it to make it for laser.
Okay. So yeah, and this is all very, I'm going to say pretty new. And so you're seeing a lot, but like I started on when I said I did it about as hard as you could do it, I'm not far off from there. Like the programs that I was using to generate files were very non-user friendly. In fact, I was using a free version, and the company that I bought it from, I figured out how to use it and get around the free limitations by like doubling the size of the file because it cut it in half and things like that. So I was doing that for a while because I was just intermittently doing it. And eventually I'm like, I need to pay this company. This has been so awesome for me. And I went to buy the license, and it wasn't on the website. I had to contact them. They were like, why would you want to buy that? Why aren't you using this other software? It's way better. And I said, all right, I've been using it for 3 years. I want to pay you for having used that for 3 years. And so I gave him the $30 for the software. It wasn't expensive. And then this weekend I started using the software he was trying to point me to. And I was like, yeah, I should have done that so long ago. It was so much better. And it was closer to the VCarve software. Very much like, here's your platen, and I'll go through that if people want to stick around for it.
Yeah, it's the same thing, they keep improving it.
Yeah, it's
6 months they come out with the updates.
Yep. And these aren't, again, it's $40 for the new software. I mean, he was like, for 10 extra bucks, you can get this one, and it does way more. And so it was very nice of him, and I still wanted to pay him for it.
Are these companies U.S. companies for the software?
The software, I'm not positive. It's called Lightburn. I'm not sure who sells it, honestly. If I wanted to do it at work, I'd have to know that. At home, the worst case is our logo might be over in China now.
What's the price range of the CNC?
All right, so this guy was less than $100. He would do, you can see its range of motion. It pretty much is about, it fills, about, I think it was about 4 inches square. And all you do is you feed it a bitmap and a power, and you say go. And it'll kind of do a trace of where it's going to do, and it gives you an opportunity to like see it, and you either move it or not, hit go. And it actually was working, and I was trying to like piecemeal a bunch of stuff to do that cutting board together with it. Man, I spent a lot of time, like I had a little jigsaw puzzle style, sets of text and everything. I must have spent weeks dinking with that, and then the laser burned out on it. I've actually stolen parts off of it at this point. So, but it's an interesting, interesting conversation piece. I don't regret doing it. It was a $100 easy intro to lasering. I was good with it. I tend to go in cheap, see if I like the concept, and then buy what I actually want. So that was my starter laser. Like I said, I bought another El Cheapo, but much like order of magnitude more powerful. Like this was probably a half watt, or maybe a watt of electrical power and probably a third of a watt optical power. Let me do another public service announcement. This one's buyer beware. If you are going to compare an old CO2, you asked cost of.
I just wonder what the range of.
Yep. So. Yep. So up in the little tiny upper left-hand corner there, you'll see basically what you would see, a mini version of what you would see if you walked into an engraving place for like a trophy shop. They'll have a suitcase size kind of thing. They put their parts in, close the thing up. It's usually got an interlock so you can't have it on. It's good. It's a good practice. The ones that the trophy shops are using are probably in the $5,000 to $10,000 range. Maybe down into the $3,000 now. They're coming down. But they're tube type. They have a cooling system in them. They're higher power. They have a lot of optics in them because tubes don't move. You don't want those things to move. So they actually they move the mirrors around. They don't move the part or the head. And so I was really tempted to get one of those. You'll see those on eBay all day long for $400 for a CO2 version. And the next thing after you buy it, if you start to go look for stuff, you begin, it's kind of like my 3D printer. Then you see, yeah, these are great if you upgrade this, replace the motherboard, get a better power supply, maybe upgrade the laser tube. Like it basically just starts. It's a project. It's a project kit. And so anybody that's happy with them has done all these upgrades. So your $400 in, there, you're probably better off paying a couple grand for a little better system. But that's okay. So where I was going with that is that's what they call a 40 watt system. They call them K40s. That's the generic term for these Chinese entry level CO2 lasers. If you get those, you're going to plan to do all that. Now, that's 40 watts. It's generally, I believe, optical power. That means there's 40 watts of light going out of that thing, cutting power. When you look at laser engravers, you almost always will see them rated on the electrical input power. So when this one was advertised, I think it was a 1500 milliwatt, so a watt and a half. That's the power going into the input of the controller. So it was really putting out about probably somewhere in the order of an eighth to a quarter of that at best case for optical power. So it was a little dinky thing. Just to give you a comparison of why I'm saying these are take them much more seriously than a laser pointer. Laser pointers are capped, class 3 laser pointer, 3B I think it is 5 milliwatt. So these start out and 3 orders of magnitude more powerful than your laser pointer. So again, healthy respect. So my 2 laser heads on these things, one of them is he calls it a 30 watt. I don't know where he gets that, but a 30 watt, and it's a single diode, but the rating on it, the real rating on it, I think is about 7.5 watts of output power. That's a lot of power for a laser to put out 7.5 watts compared to the 40 on that entry level CO2 laser. It's just big bulky tube, you can just put more power into it. They keep coming up. Well, the next level that they've come to, my other one, and I forget which one is which because from the back I can't tell. I think this is the higher one. It doesn't have a focal adjustment because what they're actually doing on that one is they take 2 laser diodes and put a beam combiner in it. One comes in this angle, one comes in this way, and the bulk of the power comes out in one collimated output. So he's actually 15 watts now. It was amazingly more powerful when I started playing with it, and to the point that I actually at first had a hard time engraving cork because it was just singeing it. I'm literally operating in the 1 to 2% pulse width to get it to burn without burning. and I got to be moving pretty quick. It's got to be running across it pretty full clip. So anyways, that is the bulk of. Now we get into some of the stuff I've done. One of my first things that I did was I was kind of tinkering around with doing the pen turning a while back, and wanted to make a gift for someone, and his last name is Wells, and he likes Corvettes, so I found the font for a Corvette, the Chevy font, and put his last name Wells on the pen, and it's a little gear shift pen. So.
Oh yeah, I see it. Yeah.
Now, when you're doing like your bottle and your mug and the pen, you gotta go to the 4th axis.
Yep. So why don't we do an intermission? And I'll come back to that question, or we can talk about it. But yes, you need a rotary axis.
Camera, and give me a thumbs up that you did something, because I didn't see it. If not, we're going to do the raffles, and then we're going to get back into third. If you heard anything I said.
Okay, we're reconvening. I should be live. Oh, sorry. No, they're just samples.
Okay, we have some samples. We got a big competition on this. Ticket number ending in 554.
There you go.
There you go, Gary.
Pick the one you gave?
The one I gave you?
I would just zoom out.
All right, so we got.
Congratulations.
All right, so 5 and 6 got, yeah.
All right, now we got a little bit bigger one here. And you're the lucky man. Draw a winning number. Not your own, though. 556.
Not me, 556, got it.
Okay. Congratulations,
Thank you.
sir. Next, we have a package you can put your cold beer in. Let's see. So you would wonder.
And I can't draw my own ticket, huh?
No, you can't. You gotta draw mine.
565.
565. All right, let me go check mine. How about that? 565.
By default.
I think it was rigged too.
You reckon?
And we're recording.
Next one.
This is the next one.
Huh?
This is the next one.
Okay, so all right. All right, that's the next one.
You get the draw.
I'm gonna let this gentleman draw. Y'all accuse me of pulling my own if I do. 561.
All right, good.
Now you guys have to put your gold beer in.
Yeah, this is a rigged draw.
Now, you want
Okay.
the ticket?
Oh, yeah, 561?
Yes, sir. Very good.
There you go. For the coasters. Next
Coasters,
next set of
I'm gonna
coasters.
Draw another number.
I put a ticket in for coasters.
All right.
Take that one.
Take that one. 550.
Here.
All right.
Mike.
Yep.
You got something
There you
to put
go.
your cold beer on.
And that too.
You're done. Mike. You got it. Go. 563.
Right here.
Right here.
Okay.
All right, thank you, sir. And is that
Let's
it?
see.
That's it.
I believe that's it. All right, thank you, gentlemen.
That's, I gotta go back right over here.
There you go.
Oh, bam.
So I got a question right before intermission here.
So backwards.
Yeah, I know. That's hard to get used to.
Somebody said, "Hey, what do you do about the curvature. And I explained to some folks in here, normally what you would do is buy what we call a fourth axis. Like that little pen that I showed you, that one was close enough on the arc that I didn't have to worry about it yet. I think it was that one. Anyway, some of them you don't have to worry about. It just isn't that far off of the radius to worry about. But once you start getting into something like this, there's no way I'm going to be able to do that. So this was actually my very first thing I tried on this. So a fourth axis, usually you have X, Y, and Z on a milling machine. The fourth axis is usually a rotary axis, horizontal, usually to X. Normally you stop moving Y, you line up on the center line, and you start moving the part around in it. Well, on my 3D printer, it happens to move the part in Y, the table, and the head moves in X. So they minimize the amount of mass that they're having to move at any given time by splitting that up, and these parts aren't very heavy on the 3D printer, so they'll move it in one axis. So I took advantage of that. I said, I don't really want to have to mess with trying to unplug that motor, plug another motor in, so I sort of invented what I call the hot dog roller. If you ever go to the 7-Eleven and watch them heat their hot dogs, they have a little rack that constantly rolls the hot dog around. So this is lined up right below the laser, so I don't have to worry about centering the part. It's always on top. And then I have little tires that I move to wherever I want to hold the part, that the bottom of it runs on the table that's moving underneath it, and then the top part rolls on top of the tires. And it turns out that it double reverses the direction, and so what you see is what you get. If you could print it in a flat size, it actually prints it on the top. Never seen anybody do it, but then again, I don't know how many people are really needing to do that and whatever, but it works great. The one downside is because it's friction and tires and it's just kind of wobbling on top of there, you have to turn your rates down just a little bit. So I usually scan in what is called the x-axis, which would be up and down on the glass, so that I'm not bouncing the part back and forth because it moves pretty quick. And I don't generally ever try to retrace, because when it rolls back, it's kind of like if you've ever tried to retrace your tire treads. You go back over it, and no matter how careful you thought you were, you'd never get your tire tread in exactly where the old one was. That's kind of what happens here too. It creates a little bit of variation. It's not going to trace back over to the level of precision that you did it. So I try and do everything in one cut. If I'm doing it on another system, I can get by pretty well without worrying about that. So this is my option. You can buy little fourth axis for these things anywhere from, the cheapest one that's this with a motor on it basically and a little bit taller, that you'd unplug the axis and plug it into the other motor. I've seen them as low as $40. It's not going to be a great one, but it's probably as good as my hot dog roller. I just was able to do that without spending any money. I'm going to move back over to my computer setup here. There we go. And if you can pull up my desktop. So I alluded to some software. So there's three things in software that you got to kind of, that luckily this piece of software sort of does all three. If you want it to. So the first thing you need is an image of what you're going to engrave. That can get imported. That's interesting. That can get imported as a JPEG or an image. You can do it. Something I didn't talk about is you can either do what I call raster or vector. Vector is really good for lines. You can't really fill nicely with a vector. That's a very painful way to do if you start trying to fill it. You basically have to create hash lines. And so if you're doing something like all of these that you've seen, everything I've done in here pretty much since I've been off of my CNC, I do raster. So it's basically running across and it just taps the laser at every spot it wants to hit. And depending on how I've got the power setting, it taps it more frequently or less frequently as it's going by. So at 1% PWM, it'll go on for 10 milliseconds and off for 90 milliseconds. And so it's constantly cycling at that kind of rate, like 20 kilohertz. 20,000 pulses per second is what it's capable of. And so it's far beyond our visibility to see that kind of pulse rate. So you open this up just like Bob showed in his software, and you import an image. So, or I can draw an image. So I can draw a square. Okay, assuming my mouse works, I can theoretically draw a square, and I can either have it filled, I can have it open, and I can make my patterns. I can array the patterns, and just keep making my, I can actually do the drawing in here.
So you could add text and whatever you want to do in there.
Yep. Limited.
You don't want to replace it.
Oh, it was trying to save that.
Does it use the fonts as much available as it is like in Windows or whatever?
Yeah, it'll use whatever fonts you have available on your computer, I believe. I haven't tested that theory. Okay. Yep. So it, and I, if it's like other graphics programs, if you import the font that you want off the internet, you'll now have a new font. So like I will go on sometimes, and if there's a font that I can't find in the 300 or whatever that's in the list, I'll go on to a site.
Like free 1001 or something like that. I mean, just
Yeah, you can buy packages with them. You can actually upload an image and have it tell you the fonts that it's closest to, and then you can go select those and you can purchase that font. You can do a sample of it, like that Wells. I didn't actually buy the GM thing. It'll let you type in a sample, and then I just do a screenshot of it, and it shows me what it was. And for what I need, that's all I really needed. I needed a word. I didn't need, and so I'll do that. So this was my the basic image that I'd bring in. I actually created this in AutoCAD.
I was going to say, I didn't know, is that like something official that the Tidewater group has, or?
No.
No, not really.
And now it is.
What's that?
Now it is.
It is now. No.
All in favor?
Just kidding. Just kidding. No, this was just, like we've got several logos that have been done for shirts and stuff. This was one of those that had been done for shirts, so I traced over it. It was an easy one for me to reproduce. So I traced over it in AutoCAD. So all of these are vector lines. So when I brought it in, I can scale, move, organize stuff around it. It just makes it easier digitally, and I'm happy to.
So it's just like layered on there.
You can create layers and everything. So I've got this set up for my Ender 3, the printer, and so it's 220 millimeters, which is I think about 9 inches square. And so I let it operate in millimeters because I know my 3D printer gets confused when I try and do inches. It's supposed to be able to convert, but it never works out well for anybody. So I just use the millimeters and get over it.
Well, it's probably not critical inside anyway, I guess, most times.
Yeah, usually I'm not. Yeah, but I just got to start to learn to think more.
Well, this looks like it's pretty well centered really well.
Yeah, that one I took a little more care to. The other ones I was eyeballing. And the coasters, for example, I actually just did a test burn. I didn't even try and line it up. I said, it'll be about in this area. I did a test burn on, I just threw some cork down.
Is that what the circles are on that? Yeah.
I drew two, you'll see on this, there's that bluish, well, you can't really tell up there. There's that outline in it. So that was the outer perimeter, and there's a hidden layer in there where I drew the outer perimeter of the actual coaster, told it to burn those two lines. So it knew where it was, so I would home it. And so if I lost power or connection or anything, I just tell it to rehome, and then I go back and find that. And then I just drove 2 nails in there so I could stick it in there. So there's creative ways to sort of center it up. A lot of people will we'll put pegs and blocks so that they know where it is and with respect to it when you have a fixed machine.
What are the limitations when you do a JPEG, like a color image?
So limitations, good question. So everything I've done so far is one color. It's either on or off. So your image, your graphic has to be reduced in that case to a black and white, literally on or off. There's a sample, I don't think I brought it, where I tried to do what they call a dithering, where it will vary it based on a grayscale and try and give you a,
Like how depth or?
yeah, the depth of the color, and it'll burn it a little hotter and or slow it down depending on how the settings go. And you have to do a lot of sample pieces, and on wood it's really tough because, as you can tell with any of these sample pieces, you hit some darker grain and it'll burn a lot darker. You hit some lighter stuff, less absorbs, it more reflects, and it affects how dark it gets.
What's the best wood to use?
Depends on what you're going for. Something with less grain and hardwood is probably, I'm going to guess, the nicest contrast.
This has good, but you see totally the grain where the.
Yep, you can exactly see where the grain is. That's bamboo.
Yeah.
And by the way, bamboo is very much processed after. Like, it's supposedly renewable and all that, and it grows really quick, but it's got a lot of polymers and stuff in it. So I'm always like cautious about what might be coming off of that.
You need your notes.
Nah. I'll figure it out again. But as far as the limitation, you want something crisp. You don't want it too blocky because you can throw away resolution. You can't create it. Just like a bad photo. You've all taken your nice photos and then tried to send it to somebody in a text message, and it's like I can't even see what's going on there. So I try to keep it, and that's why I wanted to reproduce this in vector, because vector scales perfectly. You pull a vector in, and as long as it stays in a vector format, it knows the start and stop of a line and the curvature. If there's curvature, it doesn't care what's in between those 2 points.
What is the accuracy? I assume there's some kind of accuracy.
Yeah, it's a numerical accuracy way below. DPI, you want probably if it's a bitmap or raster file, they call it. You want something just like you would for paper. It's about the resolution of what you can print on a. Yeah, 300 is probably about all you really need. The problem is when you start scaling that. If it only started at 300, now if you scale it 10%, what does that block do?
Yeah.
You no longer have 300. You have something fractionally between where you were and what you went to. So you always want the DPI. I always like the DPI to be 5 or 6 or whatever times what I actually want to print at, because if you start scaling things, you don't want that to be you don't want it to look like garbage again. It'll get very blocky. And so you pretty much are laying this down, and you can apply it to layers. So like this new one that I just put down, that outer black around there, I can apply it to a different layer. And each layer, so like layer, I think that's on 2 right now, I can set the properties for each of these layers. And so it'll lay it over the top of the other one and treat it differently. And each print run, I can do one layer, or I can do all of the layers, or whatever combination of them. And I can tell it whether I'm going to do a fill, which is a raster, or I can do a line, which is going to carve. And the nice thing with the lines, instead of going back and forth, it'll actually trace the line. So it's a much crisper line. So whoever got the one with the sample pattern on the back, I was telling some people about the sample patterns. Well, it's the same as this one, yeah. So the sample pattern helps you dial in the feeds and speeds to get the effect that you want. And so it does a grid, and there's a website I go to that generates that file for me, and I tell it where to start. Like for cork, I started at 1%. It was the lowest I could go to. And then I went up in 1% increments up to 5. I knew I wouldn't be able to do more than 5 because I'd be completely toasting the thing. And you got to keep the feeds in a range. The feeds, if you go too fast, it starts to smudge. the cutoff isn't quite crisp. If you start to slow it down too much, then you're just there all day. And you got
Is that done in
and you-
one axis though, the test pattern thing?
when you say this is all vectored.
Yeah, vector.
Yeah. Or, sorry, raster, not vector. It's all raster. I'm trying to think if the text might have been raster, or vector, but I think it was all raster. You can tell it line. The nice thing with the line, if you go line only, you can do a kerf offset and do inlays. I've seen some beautiful work with plastics. If you can find a plastic that has the right wavelength. Spoiler alert, clear acrylic doesn't work. But they do make acrylics that cut very nicely with the laser. And that you can cut through the one and make the negative of it out of another.
And be off by one.
And normally it would be, you'd have a gap in there, but you can actually tell it to offset that with a kerf and tell it whether you're cutting inside or out and create a perfect fit. Yeah. And there's another test program that helps you dial that in of how it's cutting. So I was mentioned to Jim Francis that, we talked a while back about trying to use this for creating grid on, I'm sorry? Checkering on a gun stock. Just to give him the lines, because as you go around, so in theory you could do that, but now you've got a non-linear curvature that isn't going to help. It's going to be a little more, you could probably do it with a rotary axis, a true fourth axis that grabs the part and doesn't roll the outside, but grabs it and turns it. But it's going to take a little bit more craftiness to get that right. You're going to have to start with a model probably. And then you might get close. I don't know. That would be a fun area to explore. But I also was thinking that if you were doing a nice carving, a large carving, this would be a really slick way to be able to superimpose where your figures and stuff were, burn a light trace pattern basically to start doing your carving. Yeah, I haven't tried it, but you could definitely layer it in your graphics and apply that. And even after you started carving, you could put it back up if you had your position captured. And theoretically, you could go in and lay out the next set of graphics based on the old one. Again, it was kind of a clever thing I was saying. You don't get much simpler than these. Somebody asked cost.
Yeah, I did.
This whole system is $400. And that gives you a 20. This is made by a company called Nehe, I think it is. Neje.
A lot of websites, but I can't remember what the names were.
What is it? Oh, I thought somebody said it. Yeah. Long story how I got there. Like, they were one of the more, I'm going to say, consistent names that I was running into. And they seemed to not have terrible customers bashing them. But there was a few names that kind of percolated up. They really hit the sweet spot, in my opinion, of costs. My dual laser cost me, just to give you an idea of the technology bumps, this whole system was close to $400. That one laser head was $300 for the dual laser. So you pay a penalty for the technology of beam combining. That was where I was saying that they take two laser diodes and they combine them. So I call it the dual laser head.
Does that make it more accurate or
more powerful?
more powerful? Okay.
Yeah, it's actually lower accuracy because now you've got two beams that they're trying to combine into one, so you get a little bigger spot. It's not quite as precise, not as fine, but it's twice the power going into it. So you're going to be able to do stuff twice as fast. So, so this gives you a sense of all of this. I literally started using this Friday, so that's why I was kind of chuckling when Fran gave me credit for knowing how all this was going to work out, because I completely changed everything as of Friday.
You get busy.
So I went from the clunkier software and my laser head, my old laser head before these two burned up about a month ago, right after I said I'd do this presentation, and so I was kind of dead in the water for doing any more props or anything. So I scrambled, got the dual laser head. That didn't work out well because I couldn't get it to control right. I finally, that's why I decided to buy a full system. Well, I was waiting for that to come from China. And by the way, none of the lasers are US made. The US doesn't have anybody making laser diodes.
Or you couldn't afford it.
There is a company in Houston that will at least integrate and test them. And I do have a laser head from them, and it cost me about 3 times what this one did. So I patronized them. They are a good company. I used their software. It was their original software when they said, "Why are you buying this?" Because there's a better software out there. And I bought that software from them again. So, anyways, where was I? So this gives you a sense. I mean, it's a pretty simple graphics program. Anybody that is reasonably comfortable in like a paint program and or is pretty good in computers would figure this out. It's like printing to a printer. You go find your device and it starts talking to it, as long as you bought a system that is supported by Lightburn is the name of the software. And you set up the layers of how you want it to. I'm not going to say it's 100% intuitive, but if you've ever used any kind of CAD package, you kind of get there. It's a concept of layering or graphics program. You can do probably a lot more with your graphics, preparing the bitmaps and things if you're going to stay in bitmap mode in other software. And vector, I'm still more comfortable. I learned on AutoCAD in 1990. I've been using it for, it's hard to teach this dog that much old, you know. So I still like AutoCAD, and I still do line manipulation in AutoCAD. And so you just bring it in and start plugging, you know, whatever you want. It figures out how to layer it when you put one thing inside the other. And once you get there, it has an interface here that when you click on these, it actually connects up to the printer and it becomes the driver for the printer. And I'm real time bumping it over. I can connect a camera over the top of it, and it actually will overlay that image, and you can calibrate that image with what you see in the background, so you can start to see real time what you're looking at. Again, I haven't done that yet, but this software will allow that. So you can build an enclosure, for example, mount a webcam in there,
See remotely what's going on.
and see remotely what's going on. It's perfectly safe to watch a laser direct from a webcam.
Right. Highly recommended.
In fact, a lot of times, like when you're looking at, you know, when I do videos of what's going on, I stay out of, you know, it's usually either completely enclosed or it's got one side open, and I will bring the camera over, and I'll usually have my glasses, but I'll keep the camera between me and the laser if I really need to kind of look in that general direction, even with the glasses on. I don't like to. It's just not.
You got to be on the high side.
Don't ever believe them that, like these, you'll see Japanese or Chinese companies will say, "Oh, I've got a laser shield in front of it, so you can do it without glasses." Not a good idea. For all the reasons I said earlier, that beam can ricochet and do weird things. And why are you going to do that? You know, it's like operating your table saw without glasses. You know, we do it, but should we? Why are you going to do that? This is not a good idea, and this isn't worth a hoot for glass anyway. You know, like I wouldn't count on that. But even these more reputable ones, which have very similar glass to what it looks like they ship.
The red part is sort of.
Yeah, and it's kind of a joke because this isn't far from the distance that one that you're going to be off the part. You can still see the laser bouncing off your part very crisply. You wouldn't want that on your eyes. The damage can be instantaneous or it can be cumulative. So you don't want to think you're doing okay just because your eyes aren't burning. This isn't a great demo. I could probably do a better real-time demo, you know, video remote some other time. But I wanted to give you kind of a sense of this is very similar to what Bob was showing. It's got the controls. I've got it set up for both of these at this point. I just choose which device I want to connect to, and it tells me if I'm online or not. I have noticed it doesn't like inductive motors kicking on while it's communicating, particularly through a long cable. The glass thing, you'll notice the right-hand side of the saw blade is cut off. That's when my air compressor kicked on. Lost connection, and that was it. So I got to figure out how to better shield that or something. I think this power supply is kind of noisy, so it's probably just feeding right back through the electrical line. I don't know whether this is the same way. All right, I have probably exhausted you, and I'm happy to come back with any special topics in the future if you're brave. Or if somebody just wants to dabble, wants to play around with it, let me know. Come on over to the Nienabers.
Thank you very much.
Thanks.
He needs a microphone. Brand needs a microphone.
Is it live? Yes. Okay. Terry, thank you very much for that. That was extremely informative. I do need to tell you, back about 45 years ago, I dabbled in this, not laser, but it was a device called a duplicarver. Do any of you remember one of those things? I still have it sitting above my garage on a shelf. It's been collecting dust for a long time. But Terry, this was a great demonstration, great discussion, eye-opening of what a laser can do, and hopefully, maybe some other people might be venturing into this. I know, Bob, you've been doing some with your CNC, and not quite like this though, but it was very entertaining. The last thing we want to do is show and tell. Jim, would you like to come up and show what you have, or? Okay. Speaking of Bob, just very quickly, I had a grandson that graduated from high school out in Cincinnati, and he loves to play cribbage. And I was talking about this at one of our previous meetings, the virtual meetings, and Bob came up to me and said, "Hey, come on over to my house. I'll show you how we can do this." So he downloaded a pattern and all of that. He actually sat me down in his family room, and we talked for maybe about an hour and a half on how he programmed and how it would work. Went out to his shop and put the blank in there, and it just went bloop, bloop, just 260 holes drilled. And an hour and 5 minutes later, it was a perfect cribbage board. So that's in Cincinnati. I decided to try it myself. I did not have a CNC machine, but I did have a pattern that I downloaded off of the internet with 260 little crosses on it. So I punched every one of those little crosses, and then with a brad point drill, went to my drill press, clamped down a framing square to keep my line straight. 260 holes like that. But I decided to do something different. I found out from Rocklear that you have a swivel hinge. It glues on the top and the bottom. From Amazon, you can get these really strong magnets. And there's a magnet here and a magnet on that side. You have to make sure that the polarity is right. So when it goes around, it locks.
That's good.
And it's got your cards and the pins down below here, so you don't have to make a drawer or anything like that. And it was basically just, I say scrap. There's no such thing as scrap walnut, but I did I did make that. But that's mine. Jim, did you have something that you wanted? I know you had something back there you put.
This is at the opposite end of the woodworking spectrum from what Terry talked about tonight. But the fella came in and he had a mid-1860s clock that he needed a new crown for. And so it was a clock about this tall and whatnot. And so this is, I still have some cleanup and things to do, but this is the new crown for the clock. And the
Is that
wattage,
CNC router or something?
yeah. I've got 2 drawers full of gouges and chisels, and that's where this came from. But it's interesting that the topic of discussion is I make 2 just because if something disastrous happens with the first one, I don't have to start over. And then the second one I can use, for demos and display and things like that. But anyway, it's interesting in that this one I've almost finished the relief on the back of it. And as you can see, you cut away parts of the back and you taper from front to back on the carving, and it makes it that, it makes it a little bit lighter and more delicate and things like that. And I'm not sure if you can see from out there, but this one over here, I haven't done that yet. And if you're sitting on the shop floor drinking a beer and look at them, this one looks a little bit more blockish and beefier, and this one is a little bit more refined. But anyway, so that's my story.
Both ends of the spectrum, I guess. Well, I want to thank, yes, sir.
I want to let you know for the September meeting, the cookout will be on unless we get postponed by a hurricane, and we'll do it the next week.
Sounds good. We miss it. That's something we all look forward to. So, Pat, thank you very much. Okay, we collect $17. That can go into the treasury. We're rich. And by the way, just to make sure everybody knows, we made the decision when I checked with the board back earlier in the year, because of the conditions we've been going through with COVID. We said we aren't even going to collect the $20 this year, but come next January, we're going to come and look for you. So, so enjoy it. Okay, again, thank you very much for coming in. Chris, Gary, and Terry, thank you very much for everything that you did tonight to set up. As you can see, this is not an easy setup. This isn't just walking in, setting up a demonstration, and then packing up your box and going back out. They were here. I got here right around 6 o'clock, and they were already here moving things around. So thank you very much for what you've done. Okay, gentlemen, thank you very much. Have a great night, and we'll see you next month. Okay, have a good one.